Hello everyone, I'm Pallavi, pursuing BA at Sri Venkateshwara College of Engineering. In this video, I'll be discussing about insertion sort under the subject Design and Analysis of Algorithm. The content that will be covered in this video are insertion sort, algorithm of insertion sort, time and space complexity, applications, and advantages and disadvantages of insertion sort. Insertion sort is a simple algorithm that iterates through an array, computing each element with those before it. So considering the array of elements, the first element is considered in the sorted list and all the other elements are considered in the unsorted list. The sorted list element will be compared with the unsorted list element. The element is greater than the unsorted list element, then they are swapped. If it is less, then the next element of the unsorted list will be compared with the sorted list. Insertion sort is efficient for small data sets and it is easy to implement. Algorithm for insertion sort: set the first element to be sorted. So the array of elements will be divided into two lists, that is sorted list and unsorted list. The first element initially will be the sorted list and all the other elements will be unsorted list. So we have to set the first element to be sorted and each and every element will be compared with the unsorted. So unsorted list will be compared with the sorted list. If it is greater, that is if the unsorted list element is greater than the sorted list, then there will be no swapping. If not, there will be swapped. That is the element which is greater, the first element in the sorted list, if it is greater, it will move a position ahead. And this steps will be repeated until a sorted array is obtained. Example. Let us consider the example with elements 12, 11, 13, 5 and 6. Initially, the first element is in the sorted list and all the other elements are in the unsorted list. That is 12 is in this 12 is sorted, 11, 13, 5 and 6 are unsorted. Now 11 will be compared with 12. As 11 is less than 12, there will be exchange, the swapping takes place here. So 11 moves to this position and 12 will move one position ahead. And again, these two have been sorted. So now these two comes under sorted list and this comes under 13, 5 and 6 are now unsorted. 13 will be compared with 12 as 13 is greater than 12 and the before elements are already sorted. It is not required to compare with 11. We'll be getting the same array of elements, that is 11, 12, 13, 5 and 6. We have already checked for 11, 12, 13. So now 11, 12 and 13 comes under sorted list and 5 and 6 are under unsorted list. Now 5 will be compared with 13. As 5 is less than 13, 13 will move one position ahead and then 5 is compared with 12. As 5 is less than 12, again 12 will move one position ahead and again 5 is compared with 11. As 5 is less than 11, 11 moves one position ahead. As there are no any other elements, so this is the last element for comparing it. Then 5 comes to the place of 11. So after comparing each element, we will get the array elements as 5, 11, 12, 13 and 6. In the same way, 6 is compared with each and every element and then the same way 6 is compared with each and every element and then we get the sorted list, that is 5, 6, 11, 12 and 13. Now let us look into the algorithm. In the for loop, we have initialized I as 1 and I is less than or equal to n. N is number of elements, that is 1, 2, 3, 4, 5. So I will be less than or equal to 5 and increment of 5. Temp value will be a of I. I value is 1. A of 1 is, this is 1, right? A of 1 is 11. So we have, this is 0th element. This is 1, 2, 3 and so on. A of 1. A of 1 is what? 11. So now temp will be 11. 11 is stored as temp now. J will be equal to I minus 1. J is equal to I minus 1. That is I is 1. 1 minus 1 is 0. Now J is equal to 0. While J is greater than or equal to 0. Yes, J is equal to 0. And A of J. J value is 0. So A of 0 is 12. 12 is greater than temp value is 11. 12 is greater than 11. It is true. Both the conditions are true. Now it moves inside the while loop. A of j plus 1. J is 0. 0 plus 1 is 1 will be equal to A of j. But A of j value is 0. So A of 0 is 12. So A of 0th element, that is 12, is stored in the place of A of 1. That is in the place of 11. See, so 12 is now in the place of 11. That is A of 1th position. Then decrement of j. J is 0. So decrement of j values, you will be getting minus 1. Now again it moves to while loop. Is minus 1 greater than or equal to 0? No, this condition fails. So it comes outside the while loop and execute this condition. This line. A of j plus 1. J value is minus 1. Minus 1 plus 1 is 0. Will be equal to temp. So A of 0, this is A of 0, is equal to temp value is 11. 11. So now 11 will be stored in A of 0th position. 11 is in A of 0th position. Now it comes to follow. I will be equal to 2. A of 2. A of 2 is this one, 13. Now I is incremented. I will be equal to 2. A of 2. A of 2 is 13. Temp will be equal to 13. I minus 1 is 2 minus 1. 1. So j will be equal to 1. So now j is 1. Temp value is 13. J is greater than or equal to 0. 1 is greater than or equal to 0. Yes, it is true. And A of j. J value is 1. A of 1. A of 1 is 12. 12 is 12 greater than or equal to 13? No, it is not. So what happens? It comes outside the while loop. A of j. What is j value now? 1. 1 plus 1 is 2 is equal to temp. What is A of 2? 13 will be equal to temp. What is temp value? 13. So the value 13 will be in the same position. The value 13 will be in the same position as it is greater than the element 12. The same way it is compared with 5 and 6. Time and space complexity of insertion sort. Worst and average case time complexity of insertion sort is order of n square. Best case time complexity is order of n. Space complexity is order of 1. Optimizing with blueprints. To optimize the algorithm, we use blueprints which reduce the number of comparisons and swaps, which in turn helps in time and space. Time complexity visualized. The time complexity of insertion sort can be visualized with the help of a quadratic function showing the exponential increase in time and it takes with an increase in data size. Space complexity. Insertion sort has constant space complexity as it needs to store only one element at a time, which makes it more efficient for small data sets. Applications of insertion sort. They are used in database management, online shopping, efficient for small data sets. In database management, it is useful for particularly when dealing with small sets or performing partial sorting operations. In online shopping, it is used while implementing the shopping carts, online shopping systems where the inserted item is usually small and list is partially sorted. Efficient for small data sets. Due to simple logic and efficient memory management, insertion sort is frequently used for small data sets. It is utilized by dialers in cell phones to order call logs. Advantages and disadvantages of insertion sort. The major advantage of insertion sort is the algorithm is simple and understandable, and it will be more efficient for small data sets, and it requires less memory and also can run efficiently on almost all the machines. The major disadvantages, it will become less efficient as the number of elements is increasing, or if there are more number of elements, which make it impractical for large data sets. So this was all about insertion sort. Hope you all liked the video. Thank you.